Hello, everyone. Welcome to today's webinar, Hardening a Cleanroom AI Platform to Allow Model Training and Interference on Protected Health Information. I'm Julia Moeller, and I'm joined here by today's speaker, Ali Naqvi, Lead Product Manager of the AI Platform at Johnson Labs. Before we get started, I'd like to cover a few housekeeping items. We welcome your questions today. Please type any questions you have into the GoToWebinar control panel on the side of your screen, and we will answer those at the end of the webinar. And if you have any technical difficulties, please shoot me an email and I'll try to help you out. My email is there on the screen. And finally, we will be sending out the recording for today's webinar. So you should receive that within the next couple of days. And at this time, I'd like to turn it over to you, Ali.
Thanks, Julia. So as a product manager for the AI platform, many of the deployments that we have done at Johnson Labs in the healthcare space, they tend to go through a lot of rigorous compliance overview. And what we've found are some commonalities that are across the board for almost all of our clients in the healthcare space. One of the things that they like about our AI platform is that it can be deployed in a way that is completely off of the internet. And I will go over that architecture a little bit in a bit more depth during this presentation. Another thing is that they require that it's secure by default and out of the box. So things like Kubernetes hardening, RBAC, network controls, all of the containers have gone through rigorous image scanning, and all of the containers are just by default secure. That is another very big requirement and that we have to go through as part of compliance from our customers. And the third thing is that it should be extendable. So the platform that we have is based on Kubernetes, and because it's based on Kubernetes, it is extendable by design. Now, because of the fact that this last point is primarily about Kubernetes, I will not be going over that because that requires a completely separate discussion. However, the first 2 points are quite important, and I'd like to share my learnings for those 2 points with all of you guys. Okay, so specifically with healthcare data, there is a lot of regulation, a lot of differences in geography, and because of different countries having different requirements. Generally, the idea is that the data itself can never leave a specific geography. However, it is no longer the case that we can always be on site. Why is the PowerPoint just going? Thanks. Yeah, because of the fact that we are currently all living in a pandemic, we have more people than ever working from home. So we need to have a very strong infrastructure that supports all of the compliance and regulatory requirements to work with sensitive data. We can have globally distributed teams, and that's just the new norm now. Many companies, Microsoft, Amazon, Facebook, they're all considering office work, reconsidering office work. So we need to have systems in place that allows people in distributed teams to work on very, very sensitive data. The data itself, of course, can never leave the system where it's in, the geography where it's in. However, the people could be outside of the site. There needs to be a very good data and application layer separation. And if, for example, there's any doubt that the application system is compromised, we should be able to just quickly go in and separate those two so that the data is not leaked. Because of the fact that we have designed our AI platform on Kubernetes, one thing we found with an air-gapped system was that there was a very strong core requirement for a time check. We actually had one system come down completely because we didn't have proper network time daemon installed. So I will go over that requirement as well. Okay, so for an air-gapped system, in this diagram, what you see is kind of the entry point for users. The idea here is that you want to be able to make the user experience as seamless as possible. That correlates directly with their productivity. The easier it is for them to get into the system, the faster they will be able to work. But we have an obligation to ensure that there's proper compliance controls in place. So in this diagram, what you see here towards the right-hand side is the quick sketch of our AI platform. So here you have the identity and access manager, you have the data flow designer, cluster manager, cluster monitor, etc. All of these applications, and all of them are going through the identity and access manager. But to get to any of these applications, generally, the best design, what we found, is that there needs to be, the user needs to be on a VPN, and only on that VPN they can access a remote desktop. And this remote desktop is very limited in scope. So for example, it would have policies that are very, very granular to the data itself. So you won't have access to a file system over here. There needs to be server client encryption between the client that the user is using and the remote desktop. And there shouldn't be any access to the clipboard system, both from the parent node and from the remote desktop to the parent node itself. Another thing that we've found in terms of the compliance requirements is that for the VPN, or there needs to be two-factor authentication somewhere. It could be on the VPN, or it could be on the identity and access manager. And our AI platform supports two-factor authentication here. And in some systems, what I've seen is that the information security and risk management group requires that the two-factor authentication be present on both the VPN and on the application layer itself. So that's for the entry point. Once we've configured that, then comes how do you get access to the data itself in a secure way. So for the data layer, if you are just starting, you would have data scientists working primarily in a notebook type environment. And in the AI platform that Johnson Labs has, we have something called Notebook Hub, where they would access the data. So in the Notebook Hub, from the user perspective, all they really care about is that there's a folder and there is data in there. And if you can get to that point, then that makes their work a lot faster and their productivity higher. But to get to that point, we need to have a infrastructure in place. So for the infrastructure requirements, one thing we can do is we can have, for a distributed system, if you have multiple nodes, you can have a layer called persistent distributed storage. In our case, we use a hardened version of Rook, which is an open source Ceph-based storage. And what that allows you to do is take the storage from all of the nodes and kind of provide it to the containers as one blob or one volume, and that would be the shared volume. The amount of amount of storage available to the shared volume would be equivalent to the total amount of disk across all of the nodes. This allows a couple of benefits, but one of the most important one is you can add nodes and add disk space as you go. And the shared volume can automatically increase. Ideally, however, the better design that I've seen is that of an NFS storage, network file storage. And with network file storage, really the only difference is that there would be an NFS mount here, an additional one, and that would show up as a separate folder. The benefit of this is that you can, if there's ever a doubt that these servers are compromised, you can immediately just revoke access to the NFS storage from all of the servers very, very quickly. So for example, if another thing is that you can, if there needs to be some maintenance that needs to happen, for example, we are updating the notebook containers or some upgrading the Kubernetes in all of the nodes, we need to have internet access. So one easy way to protect the data is just to remove access to the data and then just perform your maintenance, turn off the internet, add the NFS storage back. And that process will be in compliance with information security and risk management team at the enterprise. One other consideration for an air-gapped system is that you have a distributed system without internet. So because of the fact that both NFS and Rook are distributed storages, you need to have a time check across all nodes. So the reason for that is the whole cluster needs to know when some file was updated, and it needs to be consistent across all of those nodes. If there's time drift, then we need to make sure that on one server, then we need to make sure that it's corrected automatically. And that's a reason for the NTP daemon to be present. And another thing that's necessary for the NFS storage is we need to have encrypted traffic across all those nodes. And the certificate for encrypted traffic should be present on all nodes to communicate with NFS. Okay, so let's switch gears now and talk about security. For the Cleanroom AI platform, we have worked very hard to make it secure by default. One of the big challenges that we see in the news quite often itself, that there are many applications that are widely available and widely used, but they're not secure. For example, Elasticsearch databases keep getting hacked. One of the perceptions is that if we deploy an Elasticsearch on AWS, it will automatically be secure by default. But Elasticsearch has its own suite of security tools, the XPack, which adds the security capability on top of it. So Elasticsearch by itself is not secure. And there are several applications like that that are not secure by default. There have been plenty of news articles about vulnerability analysis of images in Docker Hub, even the ones that are scanned quite often. And I will show you an example later on, that there are many image vulnerabilities that are available, are present in those images. If, let's say, another point is that if we don't have proper network security policies in the Kubernetes cluster that we have in our distributed system that we have, we can have a situation where there could be privilege escalation from one container to another, and from there onto the host. And in the worst case scenario, from the host to the user account, and then the blast radius is very high. This also relates to the container runtime access. Many times we see that some containers are running as the root user, which is very poor practice. So I will give you an idea about what a tool that you can use to limit that access. Okay, so a note about defaults. The reason why we have worked on security by default in the AI platform is because what I've seen in the past is that once you have some defaults that are set, they just tend to stay like that for a very long time. And then if you harden the system later on, it tends to break. This is just something that I found myself by experience. it's and I've also seen this this trend with other systems as well. So basically, the idea is that you have to start off with very secure defaults, so that your system um, you have positive effects on the stability of your system. But this is a very large area of discussion, and as you can see, there's image safety, container runtime, network isolation, RBAC, logging. Um, uh, Plenty of other things like kernel level exploits. So we're just going to focus on the top three, which are the basic low hanging fruits. And if you do this, it goes a long way. So one thing we can do for image safety, there's a database called the CVE, and that contains all the vulnerabilities that would be available. And these are library level vulnerabilities. It could be Python, it could be Jackson bind, a data bind vulnerability, and these are all available in this database. And there are several tools that are available. In Johnson Labs, we used these two, Trivi for local development and Anchor for our CI/CD pipeline. Anchor does license scanning as well, so it can give you an idea when you're developing an application whether or not the licenses are appropriate. For container runtime, if there is a malicious user with a shell in a container, they can access, if all of the settings are default for a Kubernetes cluster, they can elevate their privileges, they can get root access, they can compromise other systems in the account outside the cluster too. One thing that I've found that was very interesting, we've integrated in our platform, is distro-less Docker images. They work really well. There's just no shell available. And I'll show you an example of a Python application that we packaged with distro-less images. However, because they work so well and there's no shell, you do need an alternate image for her debugging. So here's an example of a Docker file where you have a build environment, and then you create a debug image from it using a Python Slim image, and then you finally use the Python 3 distro-less image for prod. That's just an example of the fact that you use this one for production, but if you ever need to debug, you can switch temporarily to this one, and you can use some of the tools to perform the debugging. So that's for container runtime. Now for network isolation, there's really one major thing that there are, of course, many things that we can do, but if we just do this one thing, it will go a long way. It's really a low-hanging fruit. It's just to say that we just by default deny all access, network access to and from every container. This is a YAML for a network policy for Kubernetes, and basically it's saying that we select all pods in this particular namespace. If there is no ingress specified, it will block everything. And in egress policy, we just want to have to be able to resolve the DNS of individual containers. And then the type of policy that it would apply to is ingress and egress. And you just create it. And for every other container, you just add very, very specific policies on what you want to allow and what you want to deny. Okay, so leads me to the conclusion. Overall, the idea behind a Cleanroom AI platform is to enable distributed teams to work on very, very sensitive data. And you need to be able to provide very strong infrastructure from a security perspective to allow distributed teams to work on the sensitive data. Why is my PowerPoint switching constantly? And to be able to do that for distributed teams, you use a RDP with VPN to allow remote access. Server nodes themselves won't contain any internet. And the authentication and authorization controls should be really well streamlined to make the user experience and their productivity high. On a data layer level, we should, my recommendation is to use NFS because of the fact that it can be easily detached in case there's a malicious actor in the system. The disk should be encrypted within a specified region for compliance, and that there should be an NTP daemon configured to make sure that there are time checks across all nodes. For infrastructure security, ensure that all images pass the vulnerability scan, and then that the containers are not running as root users. Essentially minimize the exposure of all of the tools that come with the bash, curl, wget, etc. And that the network policy between pods running in the namespace is by default deny for ingress and egress. So that's all. Julia, I'm gonna hand it over to you.
Awesome. Thanks so much, Ali. As a reminder to everyone on here, if you have any questions, feel free to type them into the control panel. And one more exciting announcement, the registration for the NLP Virtual Summit is now open. It's going to be 2 weeks long, and week 1 will include 30 unique sessions with a special NLP healthcare track. And week 2 is going to feature beginning to advanced trainings with certificates. And attendees are also going to have the opportunity to participate in a datathon and join coffee chats with speakers and industry experts. So I'm gonna paste the link in the chat now, but it's pretty simple. It's just nlpsummit.org. And there's a free admission on there, so definitely sign up today to reserve your spot. And I see a couple of people asking about the recording, so we will be sending that out within the next couple of days. And of course, feel free to reach out with anything in the meantime. But at this time, I'll thank everyone for joining. Thank you so much, Ali, and we'll see everyone on the next one.
Thank you.
Thank you.
Bye-bye.
Bye.